Hello there, and welcome to my neighborhood. I'm going to tell you something about the Hessian test for classifying extremal points for a function using the Hessian matrix, and I will also examine one example. So, wait, oh shit, it's not recording. Is it not recording? Are you recording? um, Yeah, yeah, okay, sorry. Um, this is the function that we're going to use as the example. So it's args1 means x, args2 means y. So this is the function that we're gonna envision here today. This is the function that is defining the Hessian, and then this is that function applied to the variables um, v1 and v2. So let me evaluate that. So that is the Hessian of the function here. This right here is the Hessian matrix. It's a 2 by 2 matrix, and it is obtained by taking the second derivatives, plural, because there's two of them, one with respect to x and one with respect to y, or v1, v2, sorry. And then, so that's the Hessian. Now, here's what it's going to tell you a bunch of things. First of all, let's look at the determinant of the Hessian. The determinant of the Hessian is also known as the Hessian, by the way. So it's the determinant of the Hessian, which is also called the Hessian. Now we're going to ask the question, is the Hessian ever positive? Is it ever zero, and is it ever negative? Because if the determinant is zero, that means something, and then if the determinant is ever positive, something else, and then if it's ever negative, that tells you something else. So it might tell you that no, it's never negative, which means something. And let's take a look. So all three queries found 1 point each for each question. First question was, when is the determinant positive? When is the determinant equal to zero? And when is the determinant less than zero? And there are points in each of these three categories, which means there's no there's none of these queries which ended up with no points. See, that would have been interesting if one of these had no points. Then that would tell you something like the determinant's never negative, or never positive. If you know the determinant's never positive, then you know this Hessian test will never tell you anything. The Hessian test doesn't tell you anything if the determinant is negative. All right, so by finding the what I call the derivational preimage of the two-dimensional zero vector 0, 0, we have made a partial list of candidates. We haven't necessarily found anything yet for extremal points, which will be discussed, classified as maximum, minimum, or saddle point. Saddle point, you imagine it is shaped in 3 space like a shadow, or basically like a Pringles potato chip. And in the center of that Pringles potato chip, you're not maximum. You're at not the top or the bottom. So that's called a saddle point. The other critical points, so there are critical points other than when the derivatives are all zero, are the ones where not all partials exist. That could prove to be an interesting feature. And if the constraint space is bounded, now if the constraint space is bounded, that means one thing, and if the constraint space is unbounded, then that's a type of a way to have, in some sense, unconstrained notions. So pretty much all constrained spaces are bounded, I would think. Um, and The extremely extremal points are the ones that occur either on the boundary of the constraint space or are a critical point. Okay. Um, yeah. The preimage of the vector 0, 0 is the set of all points where all partial derivatives vanish simultaneously. Imagine being in three-dimensional Euclidean space. You see about a knee-high what looks like a child's volcano, but in the shape of a bell curve as though spun around to draw a bell surface. Um, this finds the stationary points of the function. So you just so the thing is, you know, what we want to do is this is a template, and then we can just change this function to anything we want later. Oh, not anything, but um, so here are the stationary points. The stationary points, the d here is for derivative, and this is a partial derivative, meaning it's in one direction only, because there's two directions, x and y directions. This is one that they simultaneously equal 0. Um, and then this simplifies something, but I made that quiet, so I don't know what that means. And then reduce, what this is telling us is, well, let's see, let's evaluate that. So this is the first Hessian, is that. This crazy beast is the second Hessian. So it's got, this is the exact number, of course, 2 to the 5/9, which is, a number you encounter every day. Um, and the Hessian test for multivariable C2 functions to classify critical points as extrema or not extrema for F. So this is going to talk to us about indefinite, definite, and then if they're definite, are they positive definite or negative definite? We're talking about matrices. So a matrix can be negative definite or positive definite. This is the Hessian test, is looking at whether the Hessian matrix is positive determinate, definite, negative definite, or indefinite, which is when there's a saddle point. Um, this one says that the first Hessian is indefinite, so it means that it will have a saddle point at the location that we entered these things at. And then the second Hessian is negative definite, because this one's true right here. Negative definite Hessians, what that tells you is that the point is a local maximum, and if it was a local minimum, then the Hessian would be negative definite. And so here's a approximation to what our critical point in round numbers. Sorry, I'm scrolling too much. In round numbers, that's the approximation to our critical point. Here is something kind of visual, if you like to see something. Although this might make you dizzy. Okay, so that is the function that we are considering. That's just one way to visualize it. And so as you can see, there's obvious like different features. This is like an actual mountain in a sense. Like this could be something that you could turn into virtual reality. You could be climbing this way and then go down that way, and then you come around here. And so the question is, one of the critical points was 0, 0. That's this one, and then the other funky critical point was this one. The question is, looking at the contour graph, can you predict like this point, is it going to be a minimum or a maximum? Because it's one or the other. And this point here, you could ask some questions about saddle points, but it's not a candidate for a maximum or minimum. So kind of got to wonder, is this descent here? Are you going down into a valley? or you're going up into like a maximum like that. So um, notice that we found those points without drawing a graph. So it is basically possible to quote unquote see, these shapes in three-dimensional space even without drawing a graph. We figured out some things about it that helped us visualize it, although maybe not, like a picture. Um, and at 0, 0, the one of the stationary points that's seen at that point is this. And I asked if it's positive definite, negative definite, or indefinite. It's none of the above. It's false for all three. And then this point, yeah, it's neither positive definite, negative definite, nor indefinite, and that Hessian is kind of interesting. I've never seen that matrix with those kind of numbers in there. Um, so this is the Hessian in matrix form. There you go, and those are the variables. Um, and then if we want to put a telescope into the sea of extrema, we could ask ourselves, find an instant. So where is it positive definite? Depending on what the variables. Where is it negative definite? And then when is it true that it's indefinite? And for this one, it's empty, which means that 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 for that Hessian, it's never positive definite, never negative definite, and never indefinite for any value of the variables. Um, so, what does it all mean? I don't really know. Okay. Bye.